Terraforming planets has long been a dream of humanity, and Venus, Earth's twin in size and structure, stands as one of the most fascinating candidates for transformation. But turning this hellish world into a habitable environment is far from a simple task. Venus is an unforgiving planet. With surface temperatures soaring to over 900 degrees Fahrenheit, it's hotter than Mercury, despite being farther from the Sun. This searing heat is largely due to Venus's thick atmosphere, which is composed primarily of carbon dioxide. The atmosphere traps heat in a runaway greenhouse effect, creating a pressure 92 times greater than Earth's. It's like standing under the crushing weight of the ocean at a depth of nearly a mile. To make matters worse, Venus's skies are filled with clouds of sulfuric acid, blocking out sunlight and raining acidic droplets onto its barren surface. The planet rotates slowly. One day on Venus lasts 243 Earth days, and it rotates in the opposite direction of most planets. If we are to ever terraform Venus, these are the obstacles standing in our way. Step 1. Cooling the atmosphere. Before anything else, the planet needs to be cooled. Venus's overwhelming heat makes it impossible for any kind of life to survive. One proposed method for cooling Venus is to block the sunlight that heats its surface. Massive solar reflectors could be placed between Venus and the Sun, casting a shadow over the planet and allowing the temperature to drop. These reflectors would need to be enormous, about the size of the planet itself, and would take generations to build. Another option could be to seed the Venusian clouds with reflective particles, effectively enhancing the planet's albedo, its ability to reflect sunlight. This approach would also reduce the amount of heat reaching the surface, but the sheer scale of such a project would be staggering. It would take decades or even centuries for Venus to cool enough to resemble Earth. Step 2. Thinning the atmosphere. The dense, crushing atmosphere is the next challenge. Composed almost entirely of carbon dioxide, it would need to be dramatically reduced. One idea involves using technology to capture the carbon dioxide and store it or convert it into something less harmful. Introducing vast fleets of machines to scrub carbon dioxide from the air could theoretically lower the atmospheric pressure over time. Alternatively, there's the idea of redirecting icy comets from the outer solar system to crash into Venus. These comets could introduce massive amounts of water, which would not only cool the planet but also help dissolve some of the carbon dioxide. However, this strategy is risky and could cause unpredictable effects. Step 3. Introducing oxygen and water. Once Venus's atmosphere is reduced and cooled, the next step would be to create an environment more suitable for human life. Oxygen would need to be introduced, which could be done by genetically engineered microbes that can convert carbon dioxide into oxygen through photosynthesis. These microbes could spread across the planet's surface, slowly transforming the air. Water, the essential ingredient for life, would also have to be introduced. The surface of Venus is bone dry, so water would have to be imported, possibly through those same icy comets mentioned earlier. Over time, lakes, rivers, and oceans could begin to form, making Venus more Earth-like. Step 4. Stabilizing the planet's spin. Venus's slow rotation presents another problem. One day on Venus lasts longer than its year, meaning a single side of the planet would be exposed to the sun for an unbearably long time. To terraform Venus fully, its rotation would need to be sped up. This could be done by using massive space stations or asteroids to gradually change the planet's angular momentum. However, altering the rotation of a planet is an almost unimaginable challenge. It would take centuries of work and an understanding of planetary physics far beyond what we currently possess. Step 5. Building a magnetic field. Another critical factor is Venus's lack of a magnetic field. Without a magnetic field, any newly created atmosphere would be vulnerable to solar winds, which would strip away the air over time, just as it did on Mars. A magnetic field would need to be generated to protect the atmosphere and any life that might one day exist on Venus. Some scientists have suggested building massive superconducting rings around the planet's equator to generate an artificial magnetic field. Others propose using advanced technology to manipulate the planet's core, reigniting its dynamo effect to generate a natural magnetic field. These are ideas that dwell deep in the realm of future science, but without such protection, Venus would remain a fragile and dangerous place. Step 6. The new Earth. After centuries, possibly even millennia of work, Venus could be transformed into a second Earth. It would be a world where oceans lap against newly formed shores, oxygen fills the skies, and life flourishes where once there was only death. The clouds of sulfuric acid would have long disappeared, replaced by rainwater that nourishes the new biosphere. But despite these changes, Venus would always remain a dangerous world. Its slow rotation and proximity to the sun would make it prone to extreme weather events, and any malfunction in the technologies maintaining its new atmosphere could quickly revert the planet to its previous inhospitable state. The ethical dilemma. Even if we could terraform Venus, should we? This process would permanently alter a celestial body, erasing whatever natural history Venus holds. There's also the potential to destabilize Venus's position in the solar system or to introduce unforeseen consequences that could affect Earth. Terraforming Venus isn't just a technical challenge, it's a philosophical one. It forces us to confront our relationship with the cosmos. Are we destined to become cosmic gardeners, reshaping worlds in our image? Or is it better to leave the planets as they are, untouched and unspoiled by human hands? In the end, the idea of transforming Venus into a habitable world remains a distant dream, one that will take centuries to realize, if ever. But in that dream lies the tantalizing possibility of expanding humanity's reach beyond Earth, a future where we walk under alien skies and gaze upon oceans that never existed before. Terraforming Venus would be an epic and daunting task, one that requires us to manipulate the forces of nature on a scale far beyond anything we've ever attempted. It would take generations, monumental advancements in technology, and an unwavering determination. But if we could succeed, we would unlock a future where humans are no longer bound to a single world, a future where we can thrive among the stars. For now, Venus remains a hostile, deadly place, but the dream of turning it into Earth's twin, a new cradle for humanity, endures.